Here we have to find magnetic field intensity due to a circular loop. So we can draw a circular loop. So due to this circular loop, the current flowing through this loop is current I. Due to this circular loop, what is the intensity at this point P? This is point P. So for not to find this magnetic field intensity at this point P due to this circular current carrying loop, first we can consider a small current element, that is dl, which we can consider at a distance rho from the center. Now this point P, which is at a distance h meter from this center, this point is at 0, 0 h, and from this small current element, this is at a distance r. This point is at a distance r. So first we can find the magnetic field intensity due to this small current carrying element at this point P. So that is denoted as dH. So due to this small element, the magnetic field intensity will be in this at this point will be in this direction along this dH. So we know that this distance we can mark it as r, and we know that what is the magnetic field intensity due to this small current carrying element according to Biot-Savart's law. So we can write according to Biot-Savart's law, this magnetic field intensity dH due to current carrying element will be equal to 1 by 4 pi IDL cross AR by R square. So that will be equal to IDL cross R divided by 4 pi into R cube. That is AR is vector R by its magnitude is R. So the denominator there is already R square. So this denominator becomes 4 pi R cube. So dH is IDL cross R by 4 pi R cube. Now we have to define this dl cross R. So from this figure we can consider what is dl, this differential length, small differential length. So this is along this circular loop. The small dl will be, we can written as, this length is rho, and if we consider a small angle here to this dl, that is small angle here is d phi if we take. So this differential length dl can be written as this distance into this angle d phi. So that becomes rho d phi, and this vector is along a phi direction. So this differential length dl can be written as this distance into this angle. So that is rho d phi, and the direction it is acting is along a phi. So rho d phi a phi. Now what is this vector r? So in order to find this vector r, we can consider the vector addition, and this rho, this is the rho, and this is h, and this is r, and h will be along az direction, and this rho will be along this a phi direction, that is this rho will be along this direction. And if we consider the vector a rho, this rho will be towards this. So this is, we can take it as minus rho a rho plus HAZ. So this vector rho is opposite direction of my a rho. So that is minus rho a rho. Then this will be along positive AZ, so HAZ, and that will be equal to the resultant of these two vectors is R. If we consider the vector addition, this is minus rho and this is plus H, and this is r, resultant is r. Now we get that vector r is minus rho a rho plus h a z. Now what you have to find? You have to find is dl cross r. That is a cross product. So we can find the cross product by determinant. The unit vectors are a rho, a phi and a z. Then what is dl? dl is rho d phi a phi. So along a rho there is no vector is there, so that is 0. Along a phi it is rho d phi. Along a z there is 0. Now what is vector r? Minus rho a rho plus h a z. So along a rho that is minus rho. Along a phi 0. Along a z it is h. So when you find the cross product of this, we can find the answer as rho into h d phi a rho plus rho square d phi a z. Now we substitute this value to this equation of dh. So we will get dh will be equal to I into rho into h d phi a rho plus rho square d phi a z divided by 4 pi into, then what is r cube? If we consider r, this is minus rho a rho plus h a z, then what is the magnitude of r? That is equal to square root of rho square minus rho the whole square plus h square. So that becomes r cube becomes square root of rho square plus h square the whole cube. Okay. Now what you have to find here, this is due to the small dl. What you have to find? We have to find due to the whole circular disk. So that is the whole circular disk we can denote it as intensity is h. So we can find h will be integrating this dh. So for finding the magnetic field intensity due to the whole circular disk, we can consider the arrow component. So due to the small dl, this arrow, the intensity in the arrow direction will be in this direction. But if we consider this another element that is in the opposite direction of this element, so that is if we consider another element dl, so in that case the arrow direction will be in this direction. So this arrow direction and this arrow direction both are cancel out each other. So similarly for the whole disk, all the arrow components will be cancel out each other. So only the remaining is along the AZ direction. So only remaining component will be along this AZ direction. So we can find the H due to only the AZ direction. So we can denote it as DHS at AZ. This magnetic field intensity will be along the vertical axis only. Okay. Now we can substitute the value of DH. So it will be integrating. What you will get? I into this rho square. This arrow component will be cancelled out. It will not. There will be no arrow component. So the remaining is I rho square d phi AZ divided by 4 pi into square root of rho square plus h square the whole cube. Now we can take the constant terms outside. I into rho square divided by 4 pi into this rho square plus h square raised to 3 by 2. Now inside the limit, that is d phi into AZ, and this d phi, the limit will be from 0 to, the limit of phi will be from 0 to 2 pi along the whole circular whole circular disk. So the phi will be varying from 0 to 2 pi. So if we integrating this d phi, that is phi, so the answer will be I into rho square by 4 pi into rho square plus h square raised to 3 by 2. Then integrating d phi, you will get as phi, then limit applying, then 0 to 2 pi, then this will be a z is there. So the remaining is what you will get, the final answer will be I into rho square. When you substitute the phi, 2 pi, this pi and pi cancels, so remaining is I rho square into 2 into rho square plus h square raised to 3 by 2 az. So the final answer h will be I rho square by 2 into rho square plus h square raised to 3 by 2 az.